In previous lecture, we proved the condition that first variation of total potential energy is equivalent to satisfying equilibrium equation and boundary conditions. We took an example of simply supported column subjected to axial loading. We derived Euler-Lagrange equation for functional having different dependent variables and its derivative through an example. Now, we will discuss one classic problem, that is Brachistochrone problem, that led to the growth of calculus of variation. Here we used Euler-Lagrange equation for deriving the governing differential equation to design a frictionless chute between two points in a vertical plane such that body sliding under the action of its own weight, I mean through gravity, moves in the shortest interval of time. Let us discuss the Brachistochrone problem. If it is designed a frictionless chute between two points, 1 and 2. In a vertical plane, such that a body sliding under the action of its own weight. Own weight means it will move by gravity, through gravity, goes from 1 to 2 in the shortest interval of time. This you can see here, this path is in a vertical plane, and this body is moving from point 1, this is 1 I have written, this is moving, this is sliding under the action of its own weight and reaching point 2. So, what should be the path of this curve so that it will take shortest time to reach from point 1 to point 2? That we will have to find out. This is popularly known as Brachistochrone problem. Let me write down Brachistochrone problem. This is popularly known as Brachistochrone problem. For descent from 1 to 2, it is t is equal to integration from 1 to 2, it is ds by v. V is the velocity, and you can integrate from 1 to 2. If ds can be written as dx square plus dy square root of r divided by velocity v. If I write it again, if I make it limit x1 to x2, I can write it as 1 plus dy by dx whole square root of r divided by v into dx. This is the total time taken. Can we write from this figure, can I write this coordinate xy, this is point xy coordinate. So can I write mg into y, mgh, that loss in potential energy is equal to gain in kinetic energy, half m into v square. So implies v is equal to root of r of 2g y. Means from point 1 the velocity was 0, it attains a speed v when it moves down by y distance. So mgy is equal to half f square, you can write it. This is very simple. If we substitute in the expression of total time if you substitute by writing this is y, you can substitute because v is equal to 2g root over y, you can substitute here. So you can write here as this equal to, you can write is 1 by root over of 1 by root over of 2g into integration x1 to x2 to 1 plus y dash square divided by y, and it is to be root of r into dx. So this is, you can write t. So this is a functional, this you can tell, this t is integration. Can I write analogous to this? Can I write t like this? See, t is equal to, I can write from x1 to x2 into function y dash into x into dx. So here this is the functional. And in this case, this is the functional, this part. So this is the same functional. So the objective is to find, what is our objective? Objective is to find, this y of x which gives extremum for the integral t. Earlier we were using I, now it is t. It is designated as t for integral t. So we can use this Euler-Lagrange equation, this apply Euler-Lagrange equation. We can write Euler-Lagrange equation, how it is? It is del f is the functional by del y minus dy dx to del f by del y dash. Here this functional is function of single variable and its higher derivative. For this, the Euler-Lagrange equation is this which we derived in our previous lecture. Now, this is the condition. This is the condition, you can write, this is the condition where T will be extremum. So now you can go for deriving, because we know f is known to us. So once again I am writing this f here. This f is 1 plus y dash square by y root over. So this, if you substitute in this equation, Euler-Lagrange equation, let us find each term, del f by del y as well as del f by del y dash. Let us write it, del f by del y is equal to, if you write, this will be minus half into root over of 1 plus y dash square divided by y to the power 3 by 2. This is del f by del y, and del f by del y dash, we can write it as, y dash 1 plus y dash square whole to the power half divided by y to the power half. And if you substitute here in this equation, this I am writing it minus half into root over of 1 plus y dash square divided by y to the power 3 by 2 minus dy dx into, we are writing this equation, please keep it in mind, y dash into 1 plus y dash square whole to the power half divided by y to the power half. This equal to 0. This is Euler-Lagrange equation. If you simplify, implies minus half into 1 plus y dash square divided by yq. I am making complete root over, I can write it, is equal to d by dx whole into y dash divided by y multiplied by y 1 plus y dash square. This is there will be root over. To the power half is there, so because it y root over. Okay. Now, if we further simplify it, this becomes implies minus half into 1 plus y dash square divided by yq base is equal to y double dash divided by y. Here in this equation, if you see, that is dy dx of u by v form. So this will be v, you will have to write first. So here we will have to write the root of v into u, differentiation of u, that is y double dash, it is all right, plus you can write u to dy dx of y to the power minus half divided by root over of 1 plus y dash whole square. So this is all right. Now we can find this one, we will have to close. So we will have to find the value of this. How to find? This is same u by v, dy dx of u by v. Same thing you can write here. This will be y dash. This is 1 by root over of 1 plus y dash whole square root over multiplied by minus half into y to the power minus 3 by 2 into y dash, then plus y to the power minus u, then multiplied by minus v, differentiation of v, minus half into 1 plus y dash whole square whole to the power 3 by 2 into 2 y dash multiplied by y double dash. So this one, if we further, this is of this value. If you substitute it, then this becomes, this is, if you can write, this is the star and this is the star. Okay, if you substitute in this equation, implies, you can implies minus half into root over of 1 plus y dash square divided by yq is equal to y double dash divided by y multiplied by 1 plus y dash square. This is root of r minus half of, there are two terms, there are two terms. So let us write those two terms, minus half into y dash square, this y dash multiplied by this y dash square divided by root over of yq multiplied by 1 plus y dash square minus y dash square into y double dash root over divided by root over of y multiplied by 1 plus y dash square whole cube. Multiplying this equation with y to 1 plus y dash square whole root over. This if you will multiply both sides. So, what it will come? It will be implies minus half into 1 plus y dash square divided by y is equal to y double dash, because once you multiply this will be cancelled denominator. So, y double dash minus half into y dash square divided by y minus y dash square y double dash divided by 1 plus y dash square implies minus 1 by 2y is equal to y double dash into 1 by 1 plus y dash square implies y double dash is equal to minus 1 plus y dash square divided by 2y. So, this is we got, if we will simplify 1 plus 2y y double dash plus y dash square is equal to 0. If we multiply y dash, let this is equation A, multiply y dash, if we multiply y dash, multiply by y dash, then what it will be? Implies y dash plus 2y y dash y double dash plus y dash cube is equal to 0. This is what? This is since the left hand side is the derivative of y plus y into y dash square. The derivative of this is this. So, you can write y plus y into y dash square is equal to constant, because derivative of this is equal to 0. So, you can write it. If constant, if you will do the differentiation, that will become 0. So, you can write it. So, y plus y dash square is equal to c. You can write, move ahead, for c greater than 0, you can write y dash is equal to c minus y divided by y root over. With separation of variable, with separation of variable, we obtain, what we can obtain? This y divided by c minus y root over into dy is equal to dx, which can be integrated. This one if you integrate, which can be integrated to x is equal to integration y divided by c minus y root over into dy. If you integrate, there will be a constant d. So, this is equation B. If let us substitute that y is equal to c sin square t. If you substitute this, then that will be integration y by c minus y root over into dy. You can write it as, you substitute c sin square t. If you substitute, this will be integration. We are evaluating this thing, this part. We substituted y is equal to c sin square t. Then this is root over of c multiplied by sin square t divided by c minus c sin square t and dy. You will have to write dy. What is the value of dy? Dy will be 2c into sin t into cos t, cos t into dt. This is dy. This is dy. Then you can write is equal to 2c into integration sin square t into dt is equal to 2c multiplied by t by 2 minus sin 2t divided by 4. Here we used these trigonometric relations. What we did, sin square t is equal to half minus half cos 2t. We use this, then sin square t into dt, if you integrate, that will become t by 2 minus 1 by 4 sin 2t. So, that we used it here. Now, with this from equation B, if you write it as, we can write it that we got this value, we substitute here. If you substitute from B, this is x of t is equal to Ct minus c by 2 sin 2t plus d. with y of t is equal to c sin square t, which we had assumed. Yt is equal to c sin square t, we had assumed first. Where it is? Y is equal to c sin square t, we had substituted. So yt is equal to c sin square t, you can simplify as c by 2 minus c by 2 cos 2t. And since the path means this path which we had drawn in the vertical plane, this path has to pass through origin. So you can, I am writing here, since the path has to pass through point 0, 0. Then what will get? What will get? It follows that d is equal to 0. How d is equal to 0? You see, x is equal to y by c minus y root over into dy integration plus d. So if y is equal to 0, automatically y is equal to 0 and x is equal to 0. Y is equal to 0 and x is equal to 0. This implies d is equal to 0. So what, where we were? Here, since the path we have already written it, hence the path can be parameterized as this equation, this thing. How we can parameterize? X of t and y of t, that you can write as, you can write a c, you can write it as t minus sin 2t by 2 and half minus half cos 2t. So this is final derivation. So this is this path is cycloid. So what do we conclude? For this, the profile of the chute in the vertical plane should be cycloid. This path, this should be cycloid, so that the body sliding under the action of its own weight goes from 1 to 2, it will take shortest interval of time.